talk about friend functions. Friend functions blur the line between member and non-member functions. Member functions have access to private variables. Generally speaking, non-member functions do not have access to private variables. Friend function rules. So they must be declared as a friend in the friending class's specification. They are not members of the class that declares them as a friend. Nevertheless, they have access to the friending class's private features. They are defined outside of the class and do not include the name of the class and the scope resolution operator as part of the class name. So this here are not called with the dot operator in this way. We know that that can't happen since this is a way of calling class member functions. More friend function rules can be declared as friends of more than one class, and when used this way are called bridge functions. These are controversial because they weaken encapsulation. They strengthen some overloaded operators by allowing them to perform useful tasks not otherwise possible. So here's an example of declaring a function as a friend. So here we have the keyword friend. We have a function called add, returning a time object inside of the time class. Don't let that confuse you. You can have a function called add that takes two parameters of time objects and returns the time object and not have it be a class member function. Here we're declaring that this is not actually a member of the class, it's a friend of the class. So it will have access to all of these variables and all sorts of member functions that we may add, but it is not an actual member of the class. We're saying that this function is a friend of this time class. The topic of friend functions is going to correlate with this overloaded operator topic very succinctly. So here, let's bring up overloaded operators again. We'll tie it all together with the friend functions here in just a second. So there's two ways of calling an overloaded operator. Once we've created our overloaded operator, when we originally created the length class, we created an A and a B length object, and now we're able to add them together. And this is the common way of using that overloaded operator symbol. However, it is possible to use the dot operator with the overloaded operator calling name. This is legal. This syntax is never used in practice, and there's no advantage to this notation over using the more familiar functional syntax a dot operator add. So here you're just changing the name, even though you have the ability to have a plus b, having that implicit on the left and the explicit on the right. The relationship between the operands and arguments. So here we have that binary member function a on the left, that implicit argument, and that explicit argument b, a plus b. So here we can see that this correlates in order. Here we have again the unary member function. Since there is no argument being passed in, this a on the right side of this unary operator is implicitly tied to this unary operator. So overloaded operators as friend functions. So when using objects, we can implicitly add a on the left and b on the right, or b on the left and a on the right. When it comes to giving your class the ability to have anything on the left or anything on the right, something that becomes a bit different. So here we have a fraction on the left and an integer on the right, instead of a fraction on the left and a fraction on the right. Say we wanted to add just 5 to our fraction class, or to a fraction object. A dot operator and then passing in that 5 as the explicit, it works. You have to implement what's happening inside of that function, but this is not a problem, this syntax. The problem comes when we want to use 5, an integer, as our implicit argument and a as our explicit. Say you want to do 5 plus fraction as opposed to fraction plus 5. This is an illegal syntax because the dot operator is not allowed to be used with integers. So here we have one solution, and that is to use a constructor to initialize only feet as opposed to feet and inches. So here we have a friend function being defined inside the class. It has the friend keyword, the length return type, and the operator plus syntax. But instead of passing in only one variable, we're going to pass in 2 variables. So here we have an integer a on the left and a length L on the right. We're going to return the length of L dot feet plus A and then 1 dot inches. So this is an implementation of adding an integer to the length class. But pay attention to the fact that we have 2 parameters to pass in. We have an integer on the left and a length object on the right. This will cause the operator syntax to let the integer a be added on the left and the integer l, or the length class l, be added on the right. So you can also just add the prototype of this into your header file, and that would work, and then have the implementation be in the .cpp file. If you do have the implementation in the .cpp file, you don't need to keep that friend keyword. You just need to define the overloaded operator. It will automatically tie it. As long as you have the same function header and you use the friend keyword, and this prototype is in the length header file, you can define this function outside of the class specification, and it will still associate the function with the prototype.